Map making is a very important concept in a spatially driven world. Maps show us many things, most notably what is near me, what path should I take to get somewhere, relative locations, and relative size. Since maps are constructed in finite spaces, real estate is at a premium. As such, not everything is represented, and even those things that are represented aren't necessarily represented precisely. You can see a couple of examples here. Roads, rivers, cities, towns, and islands are the most common victims of something like this. Spatial reasoning is a field that assists in the interpretation of object relations. We're most familiar with situations that are simplistic: separated objects, adjacent objects, contained objects, and overlapping objects as shown here. Other relations can and do exist. Topological notions underlie these classifications. Currently, spatial reasoning is limited to what I term within-class relations, like the one you see here. I can relate any two objects that have codimension 0 to their counterpart. However, generalization forces a user to have to understand cross-class relations to adequately understand the space from a mapping form. My research is concerned with providing this bridge that can lead us from the real world into the generalized world, and conversely, from the generalized world back into the real world. The candidate mathematical concept is retraction. Retraction is a typical topological deformation operator, similar to translation, rotation, and scaling, in that it involves a continuous mapping. There are degrees of retraction, each adding a stronger condition to be met. The benefit of this type of operator is that it preserves the location of a phenomenon, guaranteeing accuracy when we must sacrifice precision. Furthermore, retraction shows us where the links must be to relate different classes of conceptual neighborhood graphs. Retracts have their drawbacks because they are limited to just being subsets. So we have to set forth a few conditions to limit their power. So for example, we need to preserve nearness of objects, relations of the initial configurations, smaller objects are retracted first, separated objects remain separated, we maintain the shape, we want the dominant orientation, and we also want the maximum extent to be maintained as well. This is a very exciting field of research that can create a far different landscape in the understanding of maps and create far more power for user-driven mapping systems for computers.